In section 3.6, it's a focus on logarithms. And you have already done a lot with logarithms and taking the derivative of them, chain rule with them. So just to recap, the derivatives with an exponential. So it's a rewrite and then multiplied by the derivative of whatever the exponent is, as we learned from chain rule. Same thing. It's a rewrite, natural log of the base, and then derivative of whatever the exponent is, d over dx. Now with logarithms, we've already done the derivative of natural log with anything right next to natural log. So it's 1 over a rewrite, 1 over a rewrite, and then multiplied by the derivative. So again, du over dx is just the derivative of u with respect to x. When you take the derivative of logs, anything with a log, this has kind of a play on change of base formula. So when you do logs and you do a change of base, it would do log u divided by log a, except for you can really do any of the bases. So it doesn't necessarily have to be log base 10u divided by log base 10a. It could also be natural log u divided by natural log a. So this comes from a play on that. It's going to be 1 over natural log of whatever the base is, multiplied by a rewrite of whatever u is, so whatever's next to the log, and then you're going to multiply by the derivative of what's next to the log. So that's just the formula for it. In problems A through D, these are all just review questions. So remember, you can rewrite the following with a sum or difference instead of multiplication, and exponents go in the very front. So you can refer back to your notes in chapter 1 for these rules. And then in problems C and D, when solving for logs, you need to move all of the constants over to one side and then combine, and then you're going to loop. So we get the log base 2 of 3x minus 1 all by itself equal to negative 10 plus 10 divided by negative a, which is 0. Loop it, 2 to the 0, that's really 1, and then just reverse your operations. Same thing with part D, combine it into a single log with a base of 6, loop it, and solve. Keep in mind the rules for logs, you can never have a negative next to the log, so that would be gone. Your only answer is x equals 2. From here, we have the very first problem, and so all of the log rules that we've ever done really come into play right here. It says find and simplify dy over dx. And they went through a really long thing. They did 1 over a rewrite multiplied by the derivative of what's next to natural log, which is this huge square root x plus 1 divided by x minus 1. Went through that, used power rule and quotient rule, simplified everything, and then ended up with negative 1 divided by x minus 1 times x plus 1. And you should be thinking there has to be an easier way. And there is. Method 2 is going to involve just splitting up the natural log. And so y is going to change into 1/2 natural log of x plus 1. And then we have minus, because it's division, 1/2 natural log x minus 1. From here, now we can actually take a derivative. So our derivative is going to be drop down the constant, 1/2 times 1 over rewrite, multiplied by the derivative of what's inside. The inside part would be times 1, drop down the constant, times 1 over rewrite, times the derivative of this. If you were to combine your fractions using all of your rules, so to subtract fractions, you need a common denominator, you would end up with x minus 1 minus x minus 1 divided by 2 times x plus 1, x minus 1. And from here, those cancel, you're left with negative 2, which reduces, and you end up with negative 1 over x plus 1, x minus 1, which is exactly what they have right here. When you're doing these problems, though, you can go ahead and, as long as you split up your logs, you can stop right there. You don't have to go any further. You don't have to get to that final answer. So by using your log rules, it just makes it a whole lot easier to simplify. So in 1 through 4, we're going to find f prime of x. So find and simplify f prime of x. And we're going to start by changing f of x into natural log And instead of the cube root, the square root of x plus 3, we can put x plus 3, it has to stay together, with the 1/2 in the front, plus natural log of sine x. And then we've got plus natural log of cosine x. So when we take the derivative, we can drop down the constant 1/2, and then it's times 1 over rewrite. And then we can multiply by the derivative of what's inside here, which the derivative of that is just 1, plus 1 over rewrite of what's next to natural log. And we're going to multiply by the derivative of sine x, which is cosine x. And then we have plus 1 over rewrite. And then you have to multiply by the derivative of what's inside of the natural log. Derivative of all c's are negative. So our final answer would be the quote-unquote simplified version. We're not going to fully combine this into a single fraction. I'm just going to leave it as 3 separate parts. We've got 2 times x plus 3 in the denominator, plus cosine over sine, that is cotangent. And then we've got minus sine over cosine, which is tangent x. Much easier than doing 1 over rewrite. And then we've got 3 different things that we're going to have to find the derivative of. In number 2, same thing. So you should be changing g of x into 2 different natural logs. So we're going to have natural log of x squared and then plus natural log of x minus 1 squared. Any exponent can go ahead and move to the front. So we're going to change it even further into 2 natural log of x plus 2 natural log of x minus 1. From there, we can find g of x. Drop down the constant times 1 over a rewrite times the derivative of that, which is just 1, plus drop down the constant times 1 over a rewrite times the derivative of x minus 1, which is just 1. So really the derivative is 2 over x plus 2 over x minus 1. And you can go ahead and leave your answer just like this. And that's how I want you to keep it. In the next page, number 3, again, split up your log. So we've got 1/3 natural log of x plus 5 minus 6 natural log of x plus 2. And go through the same process. Great opportunity to pause the screen and just make sure that you have the answer correct. And same thing with number 4. With number 4, we can go ahead and change f of x. Natural log e to the power of x squared plus natural log sine x. Great opportunity to talk about log rules. Natural log has a base of e, and this is e. Those end up canceling. So really, we've got x squared here, and we're still just on f of x. So it's just x squared plus natural log of sine x. So now we can take a derivative, and this is just straight power rule. So the derivative of x squared would be 2x, and then plus the derivative of 1 over sine is a rewrite and multiplied by the derivative of sine, which is cosine. So the entire derivative is 2x plus cosine divided by sine is cotangent x. From here on out, all of these problems are more so just bonus problems. So in here, we've got some product rule, some quotient rule, splitting up logs, chain rule, some really good problems. Take this opportunity to pause the screen, and then when you're done solving, especially these 4, go ahead and unpause it and check your answers. The only one that might have gotten you is this number 8. You cannot split up something that has addition. So that's 1 over a rewrite multiplied by the derivative. I GCF the secant x and then was able to cancel out with the secant x plus tangent x, and I was just left with then secant x. Number 9, again, a play on rules for logs. Natural log has a base of e, and then this is e, so we can go ahead and eliminate that. So really the original is 3x, and the derivative would just be 3. Number 10, you're just looking for the slope of the line, so you don't even have to do the whole thing. You're just looking for the slope. So again, make sure that you have the square root of x. Think about that as to the power of 1/2. And your slope, dy over dx, is going to be 1 over rewrite multiplied by the derivative. So we've got 1/2 x to the power of negative 1/2. Negative exponents always move to the bottom. So we've got 1 over 2 root x, and then this is going to be another root x. Root x times root x is just x. So it's just 1 over 2x, and then input e squared, 1 over 2e squared c. Number 11 is another fun one, again involving natural log. You can cancel those out. So the original function would be f of x equals x plus 1 divided by 2x. Now it says that g is the inverse of f, then g prime of 1 equals what? So you're going to have to use your inverse rules, which you replace your y and your x, and then solve for the new y. Once you solve for the new y, you're going to call that g. So you just have to divide both sides by the 2x minus 1. Now, the reason why I really like this problem is because I personally avoid quotient rule at all cost. I will bring this whole thing up to the numerator by making the exponent negative. So then when we take the derivative, g prime of x, you're just dealing with a negative 1 on the outside, and then negative 1 minus 1, that'll be negative 2. Inside stays 2x minus 1. We have to multiply by the derivative of the inside, which is just going to be the 2 then. So really we have negative 2 divided by 2x minus 1 quantity squared. Input the 1. Negative 2 divided by 2 minus 1. Negative 2 divided by 1 is letter A. Same thing with number 12. But number 12, you guys have to find the second derivative. So to get g, right, we can go ahead and go over and up. So you've got g of x equals natural log base e of 2x plus 1. But remember, I never put the e. So that is the original function. You can go ahead and take the derivative. And this is another problem where I always move the denominator up to the numerator just to avoid quotient rules. So I'm going to rewrite g as 2 times 2x plus 1 to the power of negative 1, and then I can go ahead and take a second derivative. So it's negative 2, and then to the power of negative 2 when we subtract 1. Multiplied by the 2. So really, we have negative 4 divided by 2x plus 1 squared. Number 13, we have f of x and g of x, and the derivative of y equals f of g of x at x equals e is what? So if we don't have to necessarily use chain rule right here, we have the function g, so I can go ahead and plug that into x so that we have y equals e to the power of 2 natural log x. And then using our rules, I can go ahead and change this because numbers in front really go to the exponent. So it's really e to the power of natural log x squared. Again, e is a base, natural log is the base of e. So essentially, you're taking the derivative of x squared. We've got y prime is 2x, and then just input the e. So our final answer is 2e, which is letter C. To end off, we've got the derivative of just a logarithm. And the easiest way to think about this is to use change of base. So I'm going to change this into natural log x squared divided by natural log 4. And natural log 4 is actually a number. So I'm going to change this even further to, say, 1 over natural log 4 multiplied by natural log of x squared. When we take the derivative, it's drop down the constant times, and then it's 1 over rewrite multiplied by the derivative of this. And then you can simplify your answer from there so that we have 2 divided by x natural log 4, and that's our final answer. Same thing with number 15. Rewrite it as a change of base, natural log e to the x divided by natural log 4. You can write it like this, or my preferred way is this. move the x to the side and take the derivative.